Hello everybody, Chapter 3, Lesson Foxtrot, Part 2, Inverse Trig Functions. Today we're going to evaluate some compositions of inverses, including involving unknowns, as well as solving some word problems. So let's go ahead and get started. So just a reminder, let's talk a little bit about where our solutions will show up for arc sine and arc cosine and arctan. Okay, so for arctan and arcsine, our solutions will show up in quadrants 1 and 4, and arc cosine, our solutions will show up in quadrants 1 and 2. So up until this point, when using inverse trig functions, we have had convenient unit circle ratios. So unit circle ratios are, what I call unit circle ratios, are those that show up in special right triangles, which yield for us familiar unit circle angle measures. But what do you do if these ratios are not found in special right triangles? So for example, option 1, you would use your calculator. So if you look at the following below, arctangent and negative 8.45. I don't recognize that as anything that is angle familiar to me, right? So I don't know if negative 8.45 is negative 17 pi over 6 or negative 2 pi over 3. I have no idea. That is a situation where you're going to want to use your calculator to solve that type of problem. Same thing with inverse sine of 0.2447. If you know that decimal is pi over 3, then good for you. But it's typically, if you see a value that is foreign to you, it'll likely be a calculator type problem. Just make sure that when you are evaluating those types of functions and expressions that you're in the correct mode. So for both of these, you would be in radian mode. You only use degree mode if you see a degree symbol next to the value. So I'm going to just go ahead and punch these out on my calculator so that you can attempt these at home. So if you want the arctangent of negative 8.45, make sure first of all that you're in radian mode, and then press second tangent and negative 8.45. So I am getting negative 1.453. And then inverse sine, you would press second sine and 0.2447. That's going to yield you the ratio of this is kind of interesting, 247. So this right here is a ratio, and this right here is an angle in radians. Okay, same here. This is a ratio. And I might have talked about that earlier as an angle measure, but that is a ratio, and this is an angle measure. If you're in radian mode, then that angle is in radians. If you're in degree mode, then that angle would be degrees. Okay, so let's continue. Option 2 is you may not have need for the angle. And that might not make much sense, but I'm going to do a couple of examples here where that'll bring what I'm trying to say to you into a better light here. So I think we can all agree at this point that the arc cosine of 2/3 will yield us an angle. Right? Input is a ratio. Output is an angle. Okay, so if I'm going to call that angle theta. Okay, so if I want to know tangent of theta, I just take the opposite over the adjacent side. So this angle that is yielded from arc cosine of 2/3, if I'm dealing with cosine, that is either in quadrant 1 or quadrant 2. So since cosine is positive in quadrant 1, I'm going to draw myself a triangle where the cosine of theta is 2/3. So using Pythagorean theorem, I would get an opposite side of square root of 5. Okay, so I have used the information within the parentheses here to sketch this picture, and then I find the tangent of the angle within that picture. So the tangent of theta would equal square root of 5/2. Therefore, the original expression, the tangent of the arc cosine of 2/3 is equal to square root of 5/2. In no way, shape, or form did I need my calculator to find theta. I utilized the properties of right triangles in order to solve. Let's do the next one. Okay, so this angle here, I can create that. The sine, arc sine, is either quadrant 1 or 4. Since this is a negative value, I'm going to put it in quadrant 4. That's where the y value, or the sine, is negative. So sine is -3/5. Okay, this will be theta. Therefore, using the Pythagorean theorem, I'll see that this is a 4, and the cosine of theta would then be equal to 4/5. Therefore, the cosine of the arc sine of -3/5 is equal to 4/5. All right, let's try one more. This angle, of course, will be in quadrant 1 because the cosine is positive in quadrant 1. So again, I'm going to plot 2 and 3. That'll be square root of 5. So the tangent, didn't I just do this problem? Weird. I feel like I did. Will be equal to square root of 5/2. Yeah, I think I did that exact problem. Yes, I did. Okay, cool. So now you got a repeat of that. Okay, let's do a couple more like that. Okay, on this slide, I'm going to take it maybe a step further and just kind of display to you another possible scenario where you'll have to utilize this method. Okay, so at times you'll be asked to write an expression in terms of x. Whenever you see a composition of an inverse trig function with another trig function, what you're going to do is immediately assume that you're going to be in quadrant 1. So anytime you see a question like this and you see x, you don't see just numbers, you see an x involved, immediately go to quadrant 1. Okay, so I'm going to draw an angle that has a cosine of 3x. Okay, cosine would be 3x, so that would be 3x over hypotenuse, which would be 1. Okay, now I'm going to use Pythagorean theorem. So 3x squared plus, I'll call this m for a second, m squared is equal to 1 squared. Therefore, m squared would be equal to 1 minus 9x squared. So m is equal to the square root of 1 minus 9x squared. Okay, square root 1 minus 9x squared. Okay, so this is theta, which I would call this angle. So I want the sine of that angle. The sine of that angle is the square root of 1 minus 9x squared over 1. So I have found that the sine of the arc cosine of 3x is equal to square root 1 minus 9x squared. Okay, let's try the second one. Our cosine of 3x. Well, it looks like we're dealing with the exact same triangle. So I'm not going to have to do the Pythagorean theorem again. However, now I'm looking for the cotangent of theta. So I'm going to skip right to this. Okay, now the cotangent of theta is equal to 1 over the tangent of theta. So the tangent of theta would be equal to opposite over adjacent. So the cotangent of the theta would be equal to the reciprocal of that. Okay, there you have it. Let's go to the last one. All right, the arctangent of x over root 7. Okay, tangent is positive in quadrant 1. It's negative in quadrant 4. Recall again, you want to become very familiar with this. Arctangent solutions land in quadrants 1 and 4. So since the tangent is positive in 1 but not 4, we're going to go ahead and sketch this in quadrant 1. So tangent root x over root 7. So Pythagorean theorem tells me x squared plus, not twice, just once. Only need to add it once there, genius. And we'll call this c. So c squared equals x squared plus 7. Therefore, c equals the square root of x squared plus 7. Square root x squared plus 7. I want the cosecant of that angle. So really all that a inverse trig function is saying is this is an angle. This is an angle such that the tangent is x over root 7. I don't care what the measure of it is in this case, but the cosecant is the reciprocal of sine. So the sine of this angle is going to be opposite over hypotenuse. Therefore, the cosecant will be the reciprocal. And there is your answer for that third one. Okay, let's keep moving, guys. So let's take a quick look, and you might have already kind of dug this out of this material, but let's look at how we can connect the inverse trig functions to one another. So let's let arctan of x over 14 equal arc cosine of y. Okay, I want to solve for y, so I want to make these two equivalent. So I'm going to solve for y in terms of x. So arctan of x over 14, okay, tangent x over 14 is equal to the arc cosine of y. So what I want to do is I want to equate these two and make them equivalent. That was pretty redundant. That was like, I don't even know how to say that in another way, but that was redundant. But anyways, who cares? I digress. Anyways, I want these two angles to be the same. Okay, so what I want to do is I want to find the hypotenuse. So x squared plus 14 squared is equal to c squared. So c would equal the square root of x squared plus 196. So if the arctan of x over 14 is equal to the arc cosine of y, then the arc cosine of y is the same as the arc cosine of 14 over square root of x squared plus 196. Those would be equivalent. Right? In the same right triangle, those would yield the same angle. Right? And it'd yield this angle right here. Okay, let's look at another example. Let arc cosine of x minus 2 over 2 equal arctan of y. So again, quadrant 1, anytime you see an x, you should think quadrant 1 immediately. Cosine is x minus 2 over 2. Using Pythagorean theorem, x minus 2 squared plus, we'll call this m squared is equal to 4, which is 2 squared. So m squared is equal to 4 minus x minus 2 quantity squared. So m is equal to the square root of 4 minus x minus 2 squared. Okay, so the arc cosine of x minus 2 over 2 would then have to be equal to the arctangent of opposite over adjacent, which would be square root of 4 minus x minus 2 squared over x minus 2. So notice that if these two angles are to be the same, the opposite over the hypotenuse, arc cosine of the opposite over, adjacent, the arc cosine of the adjacent over hypotenuse should be equivalent to the arctangent of the opposite over the adjacent. Just a nice way to tie those two together. Okay, I got 2 more slides on some word problems and then we'll be good for today. Okay, let's take a look at this word problem. A television camera at ground level is filming the liftoff of a space shuttle at a point 750 meters from the launch pad. You can see that in the diagram here. Let theta be the angle of elevation from the shuttle, or from to the shuttle, and let s be the height of the shuttle. So write theta as a function of s. So let's equate theta, s, and 750. So s is the opposite side of the triangle from theta, and 750 is the adjacent side from theta. Therefore, the tangent of theta is equal to s over 750. Therefore, let's write theta as a function of s. If I solve for theta, that would mean I would take the inverse tangent of s over 750. All right, so in part 2 it says find theta when s is 400, and then again when s is 1600. So theta will equal inverse tangent of 400 over 750. And then again we'll find another angle. As the rocket goes higher and higher and higher, clearly the angle is going to increase. It will never get to 90, but it could get darn close depending on how high the rocket is going. So then we'll go 1600 divided by 750. So in this case, I think what I'd like you to do is put your answer in degrees. So make sure your calculator is in degree mode. I will go ahead and do that right now. So second tangent, 400 divided by 750. And when the height of the rocket is 400 feet, the angle at which the camera must elevate is, we'll go to the nearest degree, 28 degrees. Looking at the second part, as the rocket increases to a height of 1600, that angle of elevation of the camera would have to go up to 65 degrees. Some good stuff there. Let's go to our last word problem and the last slide for today's lesson. Okay, interesting question here. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, and the angle of elevation to the top of the smokestack is 53 degrees. So let's do a quick separation here. I'm going to separate these 2 triangles, and there are 2 overlapping triangles here, both of which I'll just put blue here, where this is A and this is S. Therefore, if I were to draw these 2 triangles out, I would get something that looks kind of like this, where this angle is 35, and a second that looks like this, where this angle here is 53, and this side is A plus S, where S is the height of the smokestack. Okay, so clearly, if I could find A and then also find A plus S, I could subtract them and just get S. So I know that this side is constant at 200, so I'm going to use a little tangent method work here. So the tangent of 35 degrees is equal to A over 200. So I can multiply both sides by 200. My handwriting there is kind of sloppy. But 200 times the tangent of 35, make sure I'm in degree mode, 200 times tan 35. I'm not using any inverse work here. A will equal 140.0415. I believe we're in feet here. Okay, now let's find a plus s. So the tangent then of 53 is equal to a plus s over 200. So a plus s is equal to 200 times the tangent of 53. 200 times tan 53. And then what I'm going to do is I'm going to subtract a. Okay, so I'm going to take my answer here, which is 265.4089, and I'm going to subtract this value for a. Okay, and I screwed something up there. Let's see what we got here. Minus 140.0415. And I get, so I'm subtracting a. I'm not going to write the whole thing out. But I get that the height of the smokestack is 125.367 feet. There you have it, guys. That's actually a very practical use of this idea of right triangle trig and using the properties of that to find a length that you can't necessarily measure by hand. I mean, that would be a pretty, maybe you're not allowed in that building. It's, got razor wire around it because it's some kind of secret facility, or you just can't physically get up high enough to get a measuring tape on that thing. So pretty applicable to real life. There's some other really cool practical exercises you can use with that as well. You'll see them in the homework, so give them a try. Let me know if you got any questions, and have a great day.